So this is the second video that I'm going to make for, or that I'm making for the exponential page. What we're going to look at is how we can use repeated addition with these exponential problems and turn it into some type of a multiplication problem. The reason we want to make it a multiplication problem is because I can then use my exponent rules with like bases for multiplication, but there are no exponent rules for like bases when you are adding or subtracting. And so we want to turn it into multiplication. So I'm going to go ahead and do 3, 4, 5, and 6 in this video, and then I will pop up the key for the rest of the problems, and as always, you can ask any questions you need. So problem number 3, I love the fact that everything's a base 5. What I'm not a huge fan of is that I have repeated addition on the left side. So what I want to do is collapse this repeated addition into a multiplication problem. So we have 1, 2, 3, 4, 5, 5 to the x's. So instead of writing it out as an addition problem, what I'm going to say instead is that this is really 5 times 5 to the x. And the equal to 5 to the 25th power that just comes from the other side of the problem. So now that this is written as a multiplication problem, I can deal with these like bases. So this 5 right here is really 5 to the first. And when I'm multiplying like bases, I get to add the exponents. So this is 5 to the x plus 1. And that is 5 to the 25th still. So now, once I have those like bases, I can just drop the bases and set the exponents equal, solve for x, and I'm going to get x is equal to 24. Now, in the last video, I showed you how you could check your work. You can still do the same thing. You don't even have to do the substitute or the storing part. You could just relatively quickly write out what you've got here. I'm not sure if one thing is going to happen, so I'm going to actually do it on my calculator as I'm talking. What I'm going to test for, 1, 2, 3, 4, 5, 6. So yeah, when this pops it into a calculator, this whole left side is 2.98 times 10 to the 17th. There's a whole bunch of other decimals that are popping up there. But if I type in 5 to the 25th, I get the exact same scientific notation, so I know that the two sides are equal. Again, do you have to check it? No. Is it a nice way to know that your answer is correct? 100%. All right, I'm going to go ahead and move on to number 4. Number 4 is similar, a little twist to it, but it's similar. On the left side here, we've got 1, 2, 3, 3 to the 5th power. And on the left, I keep getting my left and my right confused. I'm going to get this right eventually. On the right side here, we have 9 to the x. I want to make this have the same base. And so I'm going to rewrite 9 as 3 squared to the x power. So on the left side, see, I told you to get it right eventually. We're going to go ahead and combine these two. So this is 3 to the first. So this is going to be just 3 to the 6th, right? Add 1 plus 5. On the right side, we've got 3 to the 2x. The only way to make this work is if our exponents now become equal to each other. Divide both sides and we get x is equal to 3. Could you check it? Of course you could. Should you check it? Probably. Is it required? No. All right, so that's 3 and 4. Let's take a look at problem number 5. So problem number 5, we need to be careful. This one is not repeated addition because this is not identical to this. There are some parts that they have in common, though. So I recognize that this 3 to the x is the same as that 3 to the x. So this is going to be a little bit weird, but what I'm going to do here is I'm actually going to factor out 2 to the 3x, because that's the part that they have in common. So when I factor out 2 to the 3x, what's left? Well, in this first part, I would still have 2 to the third left, plus, well, 2 to the third divided by 2 to the 3x divided by 2 to the 3x is just 1. And you'll notice I haven't done anything with the 576 yet. I'm going to get there, but just not quite yet. I'm pretty certain I can figure out this entire set of parentheses now. So this is going to be 2 to the 3x times 9 is equal to 576. Now, there is no way to make 2, 9, and 576 have a like base, and I don't need to. Because this is multiplication, I can just divide both sides by 9, right? There's no extra exponents there or anything like that to worry about. So 2 to the 3x is equal to 64. Now I want to create like bases. So 2 to the 3x stays, and 64 is really 2 to the 6th. All right, take out the common bases now and just work with the exponents. So 3 to the x is equal to 6, which makes, let me say it right, 3x is equal to 6, which makes x equal to 2. All right, should you check it? Probably. Do you have to? No. All right. All right, so that's problem number 5. Let's take a look at number 6. Again, this is the last one for this particular video. I will put up the answer key for everything else. Ask any questions you need to. Okay, so problem number 6. I recognize that we have 4 and 4 as my common base. I also recognize that they both share an x, so that is what I'm going to look to factor out. Okay, so 4 to the x. Let's factor that out. So 4 to the x, 1 plus 4 to the first, okay, is equal to 40. So 4 to the x times 5 is equal to 40. So 4 to the x is equal to, I'm dividing both sides by 5, so that's going to be 8. Okay. Now this is a place where practice gives you some insight into these. There is no way to write 8 as a base of 4. It can't happen. But both 4 and 8 can both be written as a base of 2. So 2 to the second is equal to 4. You also have that extra variable of x, power of x there. And 2 to the third is equal to 8. So on the left side, we've got 2 to the 2x, and on the right side, we've got 2 to the third. Drop the bases and just look at the exponents at this point. So you've got 2x is equal to 3, which makes x equal to 3/2. Okay, so I hope this has made some sense in terms of some of these different exponential problems, whether they're repeated addition, a little bit of factoring that you need to do, or the inequalities that we did in the last video. If you have any requests for anything that's on the rest of this page, I will pop up an answer key. It just won't have a video attached to it. But you can request anything that you need. Let me know what you need, and let me know what questions you have.